Okay, so we are still in Chapter 5, Section 6. This is Part B, and we don't have very much further to go. So at last we saw each other, we were in example 4, and I had given you the answers to A, B, and C. Let's go ahead and do Part D. And Part D looked like the following. So we wanted to take the derivative, and we wanted to, of the following: arc secant of e to the power of 2x. And it now is as good a time as any to show you a mistake in your textbook. Depending on your edition, this is a mistake in your textbook. So in one of the earlier editions, at least the one that we have here, you can see that they accidentally gave you two derivative formulas for arc secant, right? And obviously these are not the same formulas. So the mistake is this was supposed to be the formula for arc cosecant. So nevertheless, go ahead and just make a note to self. Since we are dealing with arc secant, we want to be using the following derivative formula. But the game is the same, right? So what we need to define u, we need to take u prime, etc. So in this case, again, u is fairly easy to establish. U is going to be equal to e to the power of 2x. All right, so if we want to be able to take the derivative, this is again just reaching back into previous videos. If you want to take, we're going to need u prime, so let's go ahead and do that. And as you recall, this is in essence just chain rule, where you're basically letting u equal 2x, and it's just remember the formula was e to the u multiplied by u prime, okay? So if you need to go back and revisit the previous video on that, feel free to, but hopefully this is this information is pretty readily available from your memory. So u prime would be 2e to the power of 2x, right? That's just e to the u times u prime. And what else? Let's take a look at our formula here. So that we know that this is going to be going here for u prime. What else do we need? Well, we need the absolute value of u, okay, multiplied by the square root of u squared. Well, let's go ahead and take u squared. So u squared, well, that's just going to be e to the 2x squared. Well, again, just like if you have x squared to the power of 3, that's just x to the power of 6, right? You could think of it, if you really wanted to, you could think of it as x squared times x squared times x squared. And of course, if you multiply like bases, you add the exponents, right? So 2 plus 2 plus 2 is 6. So the shortcut, of course, is just to, instead of adding all that out, you can just simply multiply. So if you raise a power to a power, you multiply. So e to the 2x squared would just be what? It would be e to the 4x. Okay. Now, so e to the 4x, so that's u squared. We know that that's going there. Let's go ahead and drag and drop. Let's just kind of put everything in the right spots here. So u prime, so that's going to be e to the 2x. My apologies, that should be 2e to the 2x over the absolute value of u. So in this case, the absolute value of e to the 2x multiplied by the square root of u squared, which we have determined to be e to the 4x, and minus 1. Okay. Well, let's just clean this up a little bit. First off, there's no need to even have absolute value symbols here, because it's impossible for e to the 2x to be negative, no matter what you choose for x. So we can, it wouldn't matter if you left the absolute value symbols in your answer. I would be fine with that, but we don't actually need them. And what you're going to see is, if I'm going to kind of just erase these absolute value symbols, and then hopefully you see that last little thing that we can do to simplify, and that's the fact that if you have e to the 2x here and you have e to the 2x here, they're going to just cancel out, and what you're left with is 2 over the square root of e to the 4x minus 1. And there you have it. That's your derivative. I grant you that's not exactly interesting, but again, we're just we're going through some motions here, right? We're just kind of doing some reps, developing some new derivative skills. Okay, so this will be the last problem from this section. So again, the idea is we just want to be able to take the derivative of some more complex functions. So this is what we would like to be able to take the derivative of. Now, so let's start here. So this arc sine of x is some of the new material that we've been learning. But honestly, this is a product and a chain, but this is old hat, right? This is the type of derivatives that you would have done in Calc 1. So I will, again, since it's been a little while since you were in Calc 1, we'll go ahead and go through that. So let's start with, I'm actually going to begin this problem with the second term, right? And we'll come back to the arc sine of x in just a second. So hopefully at this point you at least see that this is a product, right? And if it's a product, then you're gonna need a product rule. Now you might be pretty savvy and notice that, hey, this is also going to be a chain. But as of right now, as long as you notice that there's going to be a product, then you're up and running. Ready? So let's just let f be x, defined as x, and g be the square root of 1 minus x squared. We're going to need f prime, we're going to need g prime, both with respect to x. So let's start with f prime. So the derivative of x is just 1, so that's easy. Now, what I'm going to do is I'm going to rewrite the square root of 1 minus x squared. Let's just make life easier on ourselves. That's the same thing as 1 minus x squared to the power of 1/2. Right? Optional, but sometimes it makes our derivatives easier. So what we want is we want the derivative of this. And hopefully you already spot that that requires a chain, right? So in this case, you would have to let u equal 1 minus x squared. And you know the deal. You would need f of u, you would need f prime of u, you would need u prime. And then you put it all together and you have your chain. So in that case, let's see what we got. We'll go ahead and do that chain here. So if we let u be defined as 1 minus x squared, then we would have f of u would just be u to the power of 1/2. Now I need f prime and I need u prime. So f prime, that we've already seen that's just 1/2 u to the negative 1/2. And then, of course, u prime, the derivative of u, is just going to be negative 2x. All right, with all that, I can formulate my chain. So the chain is f prime of u multiplied by u prime. So let's just put everything in the right spots. Ready? So that's going to be 1/2 half. Now I'm leaving to the negative 1/2. I'm leaving those open parentheses because you and I both know that you have to go back in and back substitute, right? So I'm going to have to take this 1 minus x squared and put it back here. So I'll do that in just a second. And then u prime is just going to be times negative 2x. So let's go ahead and back substitute. So that's 1 minus x squared. Okay. So let's just clean this up a little bit before we go back and put it into our product formula. So first, if you have half of negative 2x, then you have half of 2 is 1, right? So you have negative x. And so that's negative x times 1 minus x squared to the power of negative 1/2. Let's go ahead and get rid of that. Let's go ahead and do two things at once. Let's get rid of the negative exponent. Right, I can get rid of, and let's turn it back to a radical. So that's negative x over the square root of 1 minus x squared. So a lot of work, I agree, but all of that just so that we can have g prime. Okay, so I'm going to erase the stuff on the bottom, and let's go ahead and put everything in the right spot. Okay, so at this point, I'm plugging in for f and g and f prime, and g prime, right? I'm just putting everything in the right spots. So let me go ahead and do that. I'm going to I'm not going to do that little bit of algebra, but I think you got it, right? So I mean, at this point you would have negative x squared over the square root of 1 minus x squared, and that would be plus the square root of 1 minus x squared. All right, so a trip down memory lane back in Calculus 1. So that, all of that work is to give us the derivative of this term. So we still got to figure out what the derivative of arc sine of x is. That's actually much easier than what we just did. So our y prime. So let's go ahead and glance up here to our derivatives, our formula for the derivative of arc sine. So it's just u prime over the square root of 1 minus u squared. So now we'll deal with arc sine of x. So I think you can agree, you'll agree with me, this is fairly easy. So if we let u be defined as x, or x is defined as u, I should say, then we need u prime, and we're obviously going to need u squared as well. So in this case, u prime would just be 1, and then u squared would be x squared. So all I'm doing at this point is taking this information and plugging it back up here for our formula. What does that look like? So that's going to be 1 u prime over the square root of 1 minus u squared. Right, so that's the formula. Okay, I'll go ahead and take this negative symbol. Oh, why did I do that? Let's try that again. I'll take this negative symbol that's in front of the x squared and just bring it out here just to make things a little neater. All right, there you have it. That is your derivative. That you could, from here, you could, plot it. You could plug in values for x to get rates of change. If you were to look the answer up in the back of the book, undoubtedly what they would do is combine these, they would combine these, right? These fractions. You'd have to get a common denominator. So if you were to look this up in the back of the book, it would look something like 2 square roots of 1 minus x squared. And that can be frustrating because, you know, if you're working out a problem and this is what you get, and then you look up an answer in the back of the book and this is what they get, you're thinking that maybe you did something wrong, but no, you didn't. All they did was just combine these, right? Just you would need a common denominator. If you want to add fractions, you have to have a common denominator, right? So if you have the square root of 1 minus x squared here and the square root of 1 minus x squared here, you can think about this as a fraction over 1. So, well, you would have to multiply this by the square root of 1 minus x squared over the square root of 1 minus x squared. Then you would finally have a common denominator, and then you could add the fractions. All right, so let's conclude. That is 5.6. Where are we going from here? So I wish Chapter 5 got a little bit more exciting, but it does not. Chapter 7 is quite exciting. I think you'll agree, but if we've just got done working on derivatives of inverse trig functions, so where do you think we're going to go next? Well, yeah, we're going to learn how to integrate inverse trig functions. So that'll be 5.7, the next video.